Okay, guys, the purpose of this video, if you go to my stat lab, again, depending on the semester that you're taking the class, these dates over here may look a little different. In fact, they very well will look different if you're not in the summer 2017 class when I'm putting up this video. But nevertheless, there's going to be an assignment called demo regression. And, these tend to be the types of videos that students like the best, because instead of giving you some theory and teaching the concepts, these videos are geared toward just doing problems. Let's go in, let's dive into problems that you'll see on your assignments on my stat lab. Let's do those things with the ultimate goal of learning more about statistics, but also preparing you to do your my stat lab assignment. So what I'm going to do is I'm going to go through assignments like you guys do. Now, I'm a really bad student because assignment 1's past due, all these things are past due, but since I've already passed the class, I'm not too worried about it. So let's go through and work these things, okay? So question number 1 is similar to a question that you will encounter. So you're given 3 scatter plots, and the calculated correlations are 0.65, negative 0.898, and 0.032. Determine which scatter plot goes with which correlation. Well, when I look through here, I see that the last one over here, the one I'm circling, has to be negative because you have a decreasing pattern. So I know that scatter plot C has to be negative, and the only negative correlation is that one. Now, the other one, I know that both of these are positive, but I know that B has to be the strongest relationship. There's not much of a linear relationship over here on A. So what I need to do is I need to choose the highest number that's positive for B. So that'd be 0.65, and then clearly the only remaining one is 0.032. So check my answer. We know it's going to be right. Fantastic. Next question. Don't you wish it was that easy? Okay, the next one says 5 people were asked how many female first cousins they had and how many male first cousins. The data are shown. That's kind of a strange problem, but okay, all right. So we can assume that the trend is linear. So finding the correlation coefficient would be reasonable to do. So calculate the correlation round to 3 decimal places. So guys, I'm going to click this little button right here, and I'm going to open this Stat Crunch. About to lose my voice. Get a little coffee in me. Now, the easiest way to find the correlation is to just go to Stat, go to Summary Stats, and go to Correlation. And I want to choose both of these. And this two-sided p-value, that's higher level stuff. We don't need that. All right, so we just need to compute the correlation, and we see it's 0.6909. But I think it wanted us to go to 3 places. So if I look at the 690, the 0.690 I have there, this 9 will bump that up to 0.691. So let's put that in. Let's check the answer. We know it's going to be right. Now, comment on the meaning of the correlation. Choose the correct interpretation below. Having many female cousins causes. Now, guys, right there, anytime you see that word causes, you know that can't be the correct answer, because regression and correlation has nothing to do with causation. You can, in fact, you can show in statistics that you can model causation, but you can't prove causation through regression. So A is the worst answer here. Okay, so B says people with many female cousins tend to have few male cousins. Well, if that were true, our correlation would be negative, because as our female cousins went up, then our male cousins would go down. So that'd be a negative correlation. C, people with many female cousins tend to have many male cousins. Okay, that's reasonable. And having many female cousins causes, there's that word again, can't be true. So guys, we can scratch out A and D right off the bat because we don't, these techniques that I'm teaching you have nothing to do with causation. So guys, the only reasonable answer there is C. And we go to the next question. So the accompanying table shows the number of millionaires and the population for 10 states. Complete parts 1 A through E. So it's going to be a little more in depth. Okay. So I want to click the data table. First thing I want to do is click this. Now I want to open up in StatCrunch. And now I am ready to perform my analysis. So what we have 10 states, we have millionaires and population. Okay, so this is all quantitative, so correlation and regression is appropriate. So I want to close this. The correlation, without doing any calculations, predict the correlation and slope will be positive or negative. Well guys, they're both going to be positive, because you would think that the more people you have, the more likelihood you're going to have millionaires. So we think the correlation is slope. You might say, if you kind of want to be kind of stubborn, I guess, you might say, well, I don't know anything about the relationship between millionaires and the population of a state. Okay, I got you. But think it through with me. If you have a state theoretically of 5 people and another one of 50 million people, okay, that's a big state, but where are you more likely to have more millionaires? Well, obviously in the state with more people. All right, make a scatter plot with the population on the x-axis and the millionaires on the y-axis. So guys, we want to come in with a graph and we want to do a scatter plot. And we want population on the X and millionaires on the Y. So we have a strong positive relationship here, don't we? Now let's go back over here and see which one of those looks the most like what we created. And guys, I think you would all agree with me. It's clearly question or answer C. Find the numerical value for the correlation. Now, guys, I'm going to, this problem here has to do with correlation and regression, so I'm going to close that down. And this time, instead of just using the summary stats for correlation like I did before, I'm going to go ahead and run all the analysis with regression and go to simple linear regression. And I am going to do population as the X and number of millionaires as the Y. Really nothing else down here needs to be, I'll do the fitted line plot. Nothing else down here needs to be found right now. And if we need to go back and add some stuff, we will. All right, so right now we want the correlation. So I forget, is it 2 places or 3 places? 3 places, okay. So the correlation is 0.993. Guys, again, it's 0.992, but because of that 7 out there, that 0.992 goes up to 0.993. Check it. We know we're right. Find the value of the slope and explain what it means in the context. Be careful with the units. All right, so it turns out the slope is, okay, let's see how many places we got to round to. Round to 4 places, okay. So the slope is 1.9283, right? Yes. So the slope is 1.9283. This slope indicates that for every increase of 100,000 in population, the number of millionaires will increase on average by how many thousand? Well, what's everything measured in? So thousands, number of millionaires. So well, it's going to be 1.9283, right? Or is it? Okay. All right. Explain why interpreting the value for the intercept does not make sense in this situation. Well, guys, the intercept is this number right here. It's 5.68. And that would say if we had a state with zero population, we would have 5.68 thousand millionaires. Well, that makes no sense, because if you have a state with no population, you can't have count of anything. So in this situation, the intercept would be the number of millionaires that live in a state with a population 0, since there would be no population, so it makes no sense. So the very first one is what we need. All right, question 4 of 4. We're just moving right along here, aren't we? So gang, let's click the data. So the data in the accompanying table are for the number of formal years, years of formal education of the fathers and mothers for 29 students in a small community college with many recent immigrants. The scatter plot not shown suggests a linear trend. So we certainly wouldn't have to go through and type all those numbers in, and the great thing about the way I'm teaching the class now is we can open this in Stack Crunch and we have our data very, very quickly. So the first thing we want to do is we want to predict the mother's education from the father's education. So I want to run statistics, regression, simple linear. I want mother as my y and father as my x. Now, how do I know that I want mother as my y? Well, in one of the previous videos, I told you that whatever you're trying to predict is your y. So you're predicting the mother's education, so it has to be your y. Let's go on down. Let's do the fitted line plot, and really from now on, let's just take this. So we want to go to 2 decimal places. So I'm going to have 3.34 plus 0.62 times the father's education level. So 3.34 and 0.62. All right, use the found regression line. Find the predicted number of years for the mother if the father has 12 years of education. So guys, all we're going to do is we're going to take 3.34 plus 0.62 times 12. So let me grab my calculator. Guys, make sure you multiply first. So I'm going to take 0.62 times 12, and then I'm going to add the 3.34. So I get, we ran to 2 places, so what I get is 24.85. Okay, now I think what's going on here, I'm really glad that happened. 0.62 plus, oh shoot, guys, I messed up. I multiplied instead of added 3.34. Should be 10.78. That really wasn't anything but just a bozo moment. I hit multiplication instead of add. Okay. Using the found regression line, find the predicted number of years for a mother if the father has 4 years of education. So that's going to be the same thing. We're going to take 0.62 times 4, and then we're going to add, not multiply like I did, 3.34 to get 5.82. All right, find and report the regression equation for predicting the father's education from the mother's. So guys, we need to adjust. We can go back in stat, regression, but this time we want our y to be father and our x to be mother. And I want the fitted line plot, always. And now we have that information. So something actually kind of handy to do. Well, we can just do it this way. So I want the regression model. So let's get it. So I have so father. Well, we have 2.81 plus 0.63. So 2.81 and 0.63. Use the found regression to predict the year's father if the mother has 12. So guys, I'm going to exit full screen. I have this set up over here. Where I'm actually doing my work. So what I would do in this next problem, let me make sure that I'm on track here. So 12 years of education. What I would do is I would take 0.63 times 12, and then I would add the vertical intercept to get 10.37. All right, same thing for 4 years of education. Gang, I would do the same thing. I would take 0.63 times 4, and then I would add the 2.81. So 5.33. All right, what phenomenon does this demonstrate? Choose the correct answer below. Extrapolation, because values of the predictor variable that are far from the mean lead to responses that are closer to the mean. Okay. Regression toward the mean, because the regression line is used to make predictions beyond the range of the data. Extrapolation, because the regression line is used to make predictions beyond the range of data. And then finally, regression toward the mean, because the values of the predictor variable that are far from the mean lead to responses that are closer to the mean. Well, let's go back and look at our information here. We have zeros on both. So the values that we're having a hard time wrapping my head around this problem. So 12 and 4, 5.82. Okay, I think the point that they're making here is, and I think they've worded it kind of strangely. If you notice here that for 12, when you predict the father's education for the mother of 12, notice that you get a value less than. And notice when you have predict the opposite using 12, you get a predicted value that's less. But when you choose something that's far from the mean, you get a higher level predicted value. So extrapolation doesn't apply here, because extrapolation would be if we tried to predict a value outside the range of the sample data. So, for example, the highest, let's say we're predicting mother's education from father's education. I can only predict values from a 0 to a 16. Because here's what happens. Let me go back over. This is a good place to insert a teaching moment. So if I have a scatter plot and I have my x minimum value and I have my x maximum value, whatever it may be. Now in our problem, I think we said that was what, 0 to 16? Is that right? So let's say we're predicting mother, and I'll just go ahead and write it on the scatter plot from father's education. So the smallest father's education level I see is a 0, and the highest that I see is a 16, which would, to me, would indicate 4 years of college. Now let's go back over here and take a look at that. So I've got a 0 as the min and a 16 as the max. So I gather my data, and I have data from here up to here, and I build this regression model for prediction. But let's say later I come in with a father of a 22. Well, if I try to predict y for a value outside the range of the sample data that I'm given, then that is called extrapolation. Extrapolation is not appropriate. Now, why not? Because I built this linear regression model on my data, right? And my data ranges from 0 to 16. What happens from 16 to 22, 16 to 25? This model may get out here and then just do something wacky, right? We don't know what happens out here because we don't have data out there. It'd be kind of like collecting data on 7th grade middle school students and trying to use that model to predict some phenomena on nursing home. It's just not appropriate. The model wasn't built for education levels of 22. The model was built on education levels from 0 to 16. So I can only use my model to predict values between the minimum value and the maximum value. And if I try to predict something outside that range, it's called extrapolation. Now, if we go back to our problem here, you can see that we're not trying to do perform something of extrapolation because we use 4 and 12, which is included in, or at least I think it is. I didn't check the mother's. Mother's ranges from 0 to 15, no, to 18. Okay, so we're not doing extrapolation because the values that we're trying to predict for, in both cases, 12 and 4 and 12 and 4 are included between the x-min and the x-max. So what I have here is I have my correct answer is either going to be B or D. So B says regression toward the mean because the regression line toward the mean because values for the predictor value that are that far lead to responses that are closer to the mean. Regression toward the mean because the regression line is used to make predictions beyond the range of the data. Well, guys, our answer has to be D because nothing else makes sense. It's not extrapolation, so cross out A and C. And regression toward the mean because the regression line is used to make predictions beyond the range of data, but it's not. 4 and 12 are both in our range of data. Well, gang, that's good. We've finished. Hit save. and we save the results, and we get a 100 out of 100. Now let me show you what I'm going to do. Let me show you what happens on my end. When I go up here and do change weights, I go in and set the weights for all of your assignments. Anything that is a quiz has a 25 weight. Okay, so you've had so far 2 quizzes. You've had your email response, which all of you did very well. I'm going to make this a 25-point quiz. So as you follow through this assignment and work along with me, you're going to get credit toward a quiz. Now, it's only worth 1/4 of a regular assignment, and you're going to have more quizzes. You're going to have more demos. So to be consistent, anytime you see assignment there, assignment 1, assignment 2, assignment 3, assignment 4, assignment 5, that's going to be a 100-point assignment. Anytime you see a quiz or a demo, quiz is going to be one of those sneaky quizzes. Demo is going to be one of those that you're going to follow along with in a video, just like you are in this one, and you're going to submit the answers, and that will be counted as a quiz. So I hope that's clear. If it's not, stop and see me, and or send an email. I really don't know how I could explain it any more clearly than that. So, guys, I'm done. Have a great one. See you soon.